Here's problem 3024. Two long straight parallel wires separated by a distance of 20 centimeters carry currents of 30 amps and 40 amps in opposite directions. What is the magnitude of the resulting magnetic field at a point that is 15 centimeters from the wire carrying the 30 amp current and 25 centimeters from the other wire? Well, this is really describing a 3-4-5 triangle. If we have two wires, let's put one of them at the origin. I want to say that is 40 amps. And then we have another wire, and that is 30 amps, and the currents are going in opposite directions. And they are 20 centimeters apart. And then we have a point that is 15 centimeters from the 30 amp current and 25 centimeters from the 40 amp current. So we do have a 3-4-5 triangle. As we're looking at this, if I look at this current 2, there will be a magnetic field going circularly around it like this. And in particular, at the point P that we're looking at, that magnetic field would be strictly to the left. So I'm going to call that B2, to the left like that. And we'll also have a magnetic field going circularly around these I1, and by the right-hand rule it would be going clockwise like this. And so that will be perpendicular or tangent on that circle, coming down like this. Now looking at triangles here, if I look at this radius here, we'll have a right angle here. And if I call this theta, let's call this other angle alpha, so that theta plus alpha equals 90 degrees. But if I look at this, then if this angle over here is alpha, then this angle up here must also be theta, because they are complementary, and that also is a right angle from the vertical to the horizontal. Okay, so if we can find the magnitude of these two magnetic fields, we can break them up into components, then add them together vectorially. So that's what we're going to do. So the magnitude of B1 is going to be mu naught I1 over 2 pi R1 for a long wire. Mu naught is 4 pi times 10 to the minus 7. I1 is 40 amps. R1 is 25 centimeters, 0.25 meters. So this is going to be 8 times 10 to the minus 6 over 2.5 times 10 to the minus 1, and that is going to be 3.2 times 10 to the minus 5 Tesla. So that is B1. It's got two components. Let's worry about that in a moment. B2 is mu naught I2 over 2 pi R2, 4 pi times 10 to the minus 7 times 30 amps over 2 pi, and we're only 15 centimeters away, so that's 0.15 meters. So we're going to end up with 6 times 10 to the minus 6 over 1.5 times 10 to the minus 1, which will be 4 times 10 to the minus 5 Tesla. And that's totally in the negative x direction as we've drawn it, because it's tangent on that circle. So as a vector, B2 is equal to a negative 4 times 10 to the minus 5 I Tesla. It's totally in the negative x direction. We want to find the components of B1, and we know it's coming down like this at an angle theta, like that. So we're going to have a positive x component and a negative y component. And so as a vector, it's going to look like this. It's going to be magnitude cosine theta I minus B1 sine theta j. Thing is, what is the cosine theta and what's the sine? Well, if I look at this right triangle, with theta is identified as such, then the cosine theta will be the adjacent over the hypotenuse, 15 over 25, so that will be 3/5, and the sine will be the opposite over the hypotenuse, 20 over 25, 4/5. So this is going to equal B1 times 3/5 I minus B1 times 4/5 j. Let's go to the new screen. B1 being 3.2 times 10 minus 5. So our vector is going to be 3.2 times 10 minus 5 times 4/5 I minus 3/5 j. So what does that give me? 2.56 times 10 minus 5 I minus 1.92 times 10 minus 5 j Tesla. Alright, so that is our other vector, B1. We want to add these two fields together. So our total field is B1 plus B2 in the vector sense. Our i's are going to add together, and we're going to end up with, oops, I got these reversed. This should have been 3/5 I for the cosine and 4/5 I for the sine. I had it right on the previous screen. So this is 1.92, and this is 2.56. Okay, let's add these together now, and we have, for our I direction, we're going to have 1.92 minus 4 times 10 to the minus 5 in the I direction minus 2.56 times 10 minus 5 in the j direction. So it's going to equal a negative 2.08 times 10 minus 5 I minus 2.56 times 10 minus 5j. The magnitude of our magnetic field then would be equal to a negative 2.08 squared plus a negative 2.56 squared, all this square root, times 10 to the minus 5. And that's going to equal what? 3.298, we'll say 3.30 times 10 to the minus 5 Tesla. Or we could say 33 microtesla would be the magnitude of that magnetic field from these two wires at point P. So 3.3 times 10 minus 5 Tesla, or 33 microtesla, is the magnitude of that field.